Traditional metrology. Collecting data can be slow and expensive. Average cost can be upwards of $12 per dimension inspected. There are many dimensions to measure and evaluate in order to identify the few specific features that may or may not match the CAD model, or show the design intent if it's ever defined. More importantly, if the feature is not dimensioned, it likely won't be inspected. Your analysis is based on interpretation of the 2D drawing, and interpretations can differ depending on the experience of the inspector. There is no validation of the CAD database. Traditional metrology also can be labor-intensive, requiring specialty qualified resources such as CMMs and optical measurements machines. Many times there's a redundant evaluation of data. How many times have you heard "measure it again" only to find a different value? This is a markup for using traditional metrology to find a deviation on a part. There were 711 dimensions on 3 sheets. There were 2 dimensions that were out of tolerance. To show you how inefficient and expensive traditional metrology can be, this took 264 hours for 3 cavities for a total cost of $79,000 to inspect this, and more importantly, it took 32 days. 3D scanning for inspection. Collecting data is fast and relatively inexpensive. You design in 3D, so why not inspect in 3D and allow the creators to inspect their own work product? As you'll see, work product and reporting is graphical and textural. The CAD model is inspected as well as the as-manufactured part, which is scanned, compared, and measured completely in millions of locations simultaneously. You can quickly identify what is correct and acceptable, and focus your energy on elements which may require further analysis or action. There are 3 elements in 3D scanning for inspection: dimensional analysis, form analysis, and reporting. It's that simple. How do you do 3D scanning for inspection? Parts are arranged in a frame and placed on a gantry, where the Surveyor 3D laser scanning system passes a line laser over each face and surface of the part. As you can see from the video, the part is rotated, and the part is completely observed by the laser, and all of the points are collected in real time. A user can see exactly where he may need to get additional points, and the output is what's known as the point cloud, which is an accurate 3D representation of the part. The point cloud is superimposed on top of the CAD model, either using algorithms, which do a best fit, or using datums and features which reflect the design intent. Each point is given distance from the CAD model and is assigned a color. All of the points are taken collectively and merged into what is known as a 3D color map. The colors are keyed to the tolerances shown in the scale on the left. They are blended together, so it's very easy to quickly see where a part may deviate from the acceptable tolerance range, which is shown in green. An operator can also ask specific distances in given areas and show them as annotations, as in this slide. The same tolerance scale is shown on the left for specific areas. By the use of cross-sections, traditional metrology and measurements and linear dimensions can be made and compared with the CAD model, which is shown in magenta and black, which is the scanned object. All of this data is collected to be shown in a report. One advantage of 3D scanning for inspection is to show geometric dimensioning and tolerance. In this case, only the surfaces involved in the flatness callout of 30 thousandths are shown. All the areas in green are within tolerance, and the area in the upper part of the image is out of tolerance by 32 thousandths, so you can quickly see where your deviation might occur. We have all looked at traditional spreadsheets trying to determine which dimension is meaningful, which dimension is out of tolerance, and which dimension is acceptable. Wouldn't it be better to have a complete 3D report showing 3D views, annotation views, GD and T, plus cross-sections showing traditional linear dimensions, and an analysis of each dimension as for how it complies in the case of multiple cavities? That is 3D scanning for inspection. For more information about 3D scanning, visit us online at laserdesign.com or send an email to info@laserdesign.com.